Hello Year 5, welcome to your last science lesson on separation. Today we're going to be investigating separating river water. I'd like you to write today's date and title, so pause the screen to do that please. Okay, have a look at this picture. These people all do the same job. What job do they have? What is their career? And what do you think they're doing? These are environmental scientists. They are collecting, in this picture, they're collecting river samples so that they can test the levels of pollution in the water. They can check if there's any minerals or anything in the water that they didn't know was there before. They can compare the river water sample with other rivers in the country. So they're environmental scientists. Okay, let's do our total recall today. What states of matter do these diagrams show? How do the particles behave? So I want you to tell me the name of the state of matter and tell me how the particles behave. And what's the difference between these particle diagrams? What's the difference between a pure gas and an impure gas? And what is dissolving? Pause the screen, have a go at your total recall in your book. Okay, the first picture where all of the particles are ordered in rows and columns, that is a solid. They're all touching, they're in orderly rows and they don't move very much. They just vibrate next to each other. That's how the particles behave in a solid. The next picture is a liquid. The particles touch, but they're very random and they can move around a little bit. So that's a liquid. And then the last particle diagram is a gas. Now the gas particles are very free. They can move in lots of different directions and they're quite quick and they're not touching. What's the difference between the particle diagrams below? So we've got two particle diagrams that are pure and they're pure solids. And then the last picture is an impure solid. What's the difference between a pure gas and an impure gas? A pure gas is only made up of one type of particle, whereas an impure gas is made up of two different types of particles. What is dissolving? You need to think back to last week's lesson. Dissolving is where something, a solid, appears to disappear in a liquid. So when we put the salt into the water and we give it a mix up, it looked like it was disappearing, but actually the particles were just breaking down and breaking down and breaking down, and the water particles were surrounding them. So it made the illusion like it's disappeared, but they just mixed together to form a solution. So you can see the diagrams there. Dissolving is when two particles mix together to make a solution. Okay, today this is all of our scientific vocabulary that we've used through the term. So we've got dissolve, which is where a soluble solid looks like it's disappeared into the liquid. Filtration, that's a method of separating a solid, an insoluble solid from a liquid. Separation is just the act of separating our components into their pure states. Solution is the mixture that we have when a soluble solid is dissolved into the liquid. The solvent is the thing that dissolves, a solid that dissolves into the liquid, and the solute is the liquid itself it's dissolved into. Do you remember all of those S words from last week? Evaporation is another type of separation. We use evaporation to separate a soluble solid, so we can heat the liquid so it turns into steam and we're left with our salt in the pan. And a formulation is a mixture where you have a specific ratio of ingredients. So a cake is an example of a formulation. You couldn't make a cake with 1 kilogram of flour. That's a lot of flour. That's 100 grams of flour and 1 egg and 1 teaspoon of sugar. It would taste horrible. So a formulation is where you have to have a set amount of ingredients or components to make up your mixture. Okay, in your book, I'd like you to write down 2 examples of a soluble solid and 2 examples of an insoluble solid. Let me remind you of these words. Soluble is a solid that can dissolve in a liquid to form a solution. So in your book, write down 2 examples of a soluble solid. An insoluble solid is a solid that cannot dissolve in a liquid to form a solution. So think of 2 solid things that do not break down to dissolve into the solution. Then, in your book, I'd like you to answer the question, how can we separate a soluble solid and how can we separate an insoluble solid? Okay, let's go through the answers. So 2 examples of a soluble solid are sugar and salt. 2 examples of an insoluble solid are rocks and sand. Anything that you put into water that doesn't dissolve though, like pasta. How can we separate a soluble solid? We have to use evaporation. And how can we separate an insoluble solid? We can use filtration or sieving. Okay, what does an environmental scientist do? They work to protect the environment and human health. So they're all about making sure that the land and the rivers and the seas are all safe, and that in turn humans are safe and healthy. And they measure the amounts of pollution in the air and rivers, and they will compare pollution levels. So they might compare rivers that are near us to rivers that are in London and see if the pollution levels are the same or different and why. So today we're going to be environmental scientists. We're going to make this river water pure. So this is my river water sample. It's made up of soil, gravel and water. If you want to have a go at this experiment today, you need to go out somewhere, get about like a dessert spoon, not even that, like half a dessert spoon, a good teaspoon of soil from somewhere, a bit of gravel, a few stones and some water. Mix it all up together and you've created your own river water sample. Okay. In your books, I'd like you to write down what state of matter these substances are in. So what is the water? Is it a liquid, a solid or a gas? What is the soil? A liquid, a solid or a gas? And what is the gravel? A liquid, a solid or a gas? Answer the question, is the sample pure or impure? What types of particles are in the river water? What makes up the river water? Are the solids soluble or insoluble? What's the difference between the 2 insoluble solids? How do we separate insoluble solids from a liquid? And what do you notice about the size of the gravel compared to the soil? So pause the screen and answer those questions in your book. Okay, let's go through the answers. What states of matters are these substances in? The water is a liquid, the soil and the gravel are both solids. Is it a pure sample or an impure sample? It's impure. We've got 3 different particle types in here that we know of. So it's impure. It's not made up of one type of particle. What types of particles are in the river water? Well, there's a clue under the picture. It's made up of soil particles, gravel particles and water particles. Are the solids soluble or insoluble? Now, soil is insoluble. However, some of it might look as if it's soluble because it might discolour the water. Okay, but we're going to say that solid is insoluble, and we're also going to say the gravel is insoluble. It doesn't dissolve. What's the difference between the 2 insoluble solids? So the soil particles are much smaller than the gravel particles. The gravel particles are quite big. How will we separate insoluble solids from a liquid? We're going to use filtration and sieving. What do you notice about the size of the gravel compared to the soil? Well, the gravel is a larger particle than the soil. Well done if you got all of those. Okay, so today you're going to plan an investigation. Then you're going to follow out your investigation or watch me do mine. And then you're going to just write a very small evaluation. What could you do better if you were to do this experiment again? Which techniques are we going to need to use to separate our river water? Well, there's no soluble solid in it, so we will not be using evaporation. We will only be using sieving for the gravel and filtration for the soil. I would like you to write a method now. So I'd like you to, a bit like you've been doing in English and reading skills, a little set of instructions. So write a list of the equipment that you'll need today. And then I'd like you to do numbered steps in your method. And I'd like you to start each step with a verb. You know the type of verb I'm on about. An imperative verb, a bossy verb. Now, you could either do that completely independently today. So you could pause the screen and go, yes, Mrs. Lee, I know exactly what I'm going to do. I'm going to write out my method. I know how I'm going to separate my river water sample and write it out. If you think to yourself, oh, I'm not sure where to start with this, on the next slide, I have written out a very simple method, but I've missed out some words that you can then fill in the gaps. So you would start with your subheading of equipment, and then you need something beginning with C, something beginning with S, something beginning with F, and then a P, and then another F. So think about what equipment you'll need today. Then your method, hold the something above the cup, something sample into the sieve, remove the something from the sieve and place it to the side. Place the something into the something and place the funnel into the cup. Pour the something of water and soil through the filter paper. Oops, too far. So you can pause this screen and have a go at writing your method and your equipment lists. Make sure you underline your equipment and method because they are the subheadings. And you need bullet points for your equipment and numbered steps for your method. Remember those verbs, those imperative verbs to start the sentences. See if you can work out your method. You don't need to use mine. You can write your own if you want to. Right, let's go through our method. So you needed a cup, a sieve, filter paper and a funnel. The method was hold the sieve above the cup, pour the river water sample into the sieve, remove the gravel from the sieve and place it to the side. Place the filter paper into the funnel and place the funnel into the cup. Pour the mixture of water and soil through the filter paper. That's our method. That's how we're going to separate it. Okay, it's experiment time. I'd like you to create your own river water sample. The sample needs to have soil, gravel and water. Your task 1 is to separate the river water sample. Challenge, can you get the water as clear as possible? So what else could you do? Could you add in some extra processes to make your river water sample really clear water? And then task 2 is going to be to evaluate your experiment. If you can't do your own experiment, you can watch me separate a river water sample and then complete task 2. Warning today that this experiment isn't as easy as the other ones. Okay, it's harder to separate, it's harder to do things. Part of today's lesson is to evaluate the experiment and say how you could do it better or what things you found difficult. So don't panic if you think, wait a second, I've really struggled to do this. This is an easy separation because this is science. It's about you thinking about processes and having a go and then evaluating how you could do it better if you did it again. Okay, so you can either create your own river water sample, follow your method, or you can watch me in the next video. Okay. This is my river water sample. So in here, I've got soil, gravel, which you can see at the bottom, and water. And we are going to separate the best we can our river water to try and get pure water. Now, if things go wrong today, that's absolutely fine because it's a science experiment and it's important that we evaluate our experiment and say how we could have made it better. So watch out because I think you might find some ways that I can improve my experiment. Okay, we're going to start then because we've got 2 solids in here. We've got soil and we've got gravel. We're going to start by filtering the gravel out using a sieve because there's gravel particles are bigger. Hopefully they'll get trapped in our sieve. So here's my beaker. Just going to pour my sample through my sieve. Hopefully it'll collect just the gravel. Now, as you can see, some of the soil has got caught in with the gravel there. So not filtered all of the... It's filtered the gravel, but it's also collected some of the soil, which is a bit annoying because it doesn't mean that it's separated completely. So that might be something I need to think about how I could improve. Could I use maybe a colander or a sieve with bigger holes so the soil falls through and then it's just the gravel I've got? Okay, that's step 1 done. Now we need to use filtration. We're going to see if we can separate the soil from the water using filtration. You need your filter paper, make sure your filter is on your beaker, and then we're going to pour our sample through. And hopefully the water that comes through will be clear. And we'll be left with just the soil. As you can see, the water that's coming through isn't completely clear, is it? I wonder how we could attempt to get the river water clearer. Because at the minute it's coming through and it's a little bit brown. Does that mean that some of the soil solids have actually dissolved into the liquid? Maybe. Can you think of a way that we could filtrate this water again, maybe, to get it even clearer? I don't think my experiment's gone that well today, do you? I've got soil in with my gravel. The water that I'm filtrating isn't very clear. How could I improve our investigation today? That's what I need you to do now. I need you to go back to your books and I need you to evaluate my experiment and work out, is there a way you can separate the items in our mixture, in our river water, so that they are all pure? Okay, if you've now thought to yourself, do you know what? I think my method needs editing a little bit. I've thought of a way that I can filtrate this river water so it's clearer than yours, Mrs. Lee. Then go back and edit your method. Make it better. Rewrite it if you need to. But what I need you to do now is evaluate your experiment. So this is task 2. So you've either watched my experiment or you've done your own, hopefully much more successfully than me. And then I want you in your book to write down 2 things that went well and 1 thing that you think you could have done better today in your investigation. Now, it doesn't need to just be 2 very short sentences and 1 thing you could do better. Try and go into a little bit more detail, try and explain to me why that thing didn't go well and the reasons behind that. Try and use all your scientific vocabulary we looked at the beginning. So that's task 2. So in your books today, you should have answered those questions. You should have written out your method. And now you're writing a very small evaluation. You can write evaluation in your book and underline it so that you've got another subheading. So pause the screen and write your evaluation. Okay, Year 5, we're going to end the lesson today with a quote that's an environmental quote. It says, "Water and air, the 2 essential fluids on which all life depends, have become global garbage cans." So environmental scientists are all about keeping the earth healthy so that humans can live from the earth. And actually, quite often we dump our rubbish or things end up in our seas and our rivers that cause pollution. So just to reflect on today, I'd like you to think about actually how can we respect our planet so that we can have clean water for all. Have a fantastic day, Year 5, and well done if you've completed the science unit on separation. Bye.